Carbohydrates part 10. In this part, we will see the point that is polysaccharides. The word itself indicates its meaning. Poly means many, and saccharides, that is saccharine units. So, carbohydrate units, when they are attached with each other in many numbers, they will form polysaccharides. These are carbohydrates in which hundreds of monosaccharide units are joined together by glycosidic linkage. They are represented by general formula C6H10O5 n times, where the value of n varies from 12 to several hundred. Polysaccharides are naturally occurring polymers. They are tasteless and water insoluble. Amorphous compounds, they form colloidal solution which readily set to gels. So they form gels. They undergo hydrolysis by acid or enzymes to yield monosaccharides. Examples are starch, cellulose, glycogen, dextrine, insulin. These are some examples of polysaccharides. And polysaccharides are of two types. They may be homopolysaccharide or heteropolysaccharides. These words give their meaning that homo means same. If that polysaccharide is made up of from same type of units, that is same type of monosaccharides, then it will be called as homopolysaccharides. And if monosaccharides, which are the components of that polysaccharide, are of more than one kind, then that polysaccharide will be known as heteropolysaccharide. So let us see one by one. So first example of polysaccharide is starch, and it has molecular formula C6H10O5N. Sources of starch. It is found in most plants, in seeds of the plants. The rich source of starch are potatoes, wheat, maize, rice, barley, and arrowroot. Starch is one of the most important source of carbohydrate in the human diet. Starch is white, amorphous, tasteless, and water insoluble substance. It swells in water to form gel. Starch on hydrolysis with dilute HCl, dilute acid, or by enzyme gives dextrine, a mixture of low molecular weight polysaccharide, maltose, and finally D-glucose. And this reaction sequence is like this. Starch converts into dextrine, dextrine to then maltose, and maltose to glucose. Starch on enzymatic hydrolysis by dietase. This is class of enzymes. Dietase use maltose, while ptyalin, that is salivary enzyme, salivary amylase, hydrolyzes it to glucose. Structural formula is starch is obtained as a mixture of two polysaccharides, namely amylose and amylopectin. These two can be separated. Amylose is soluble in water and gives deep blue color with iodine. On the other hand, amylopectin is insoluble in water and it does not give color with iodine. So their properties are different. Natural starch consists of 10 to 20% amylose and 80 to 90% of amylopectin. So amylose, it is a straight chain linear polysaccharide having only D glucose units. So this is the structure of amylose. Here only glucose units are there. That means it is homopolysaccharides. These are joined by alpha glycosidic linkage between C1 and C4. So this one C1 and C4. Its molecular weight ranges from 10,000 to 5 lakh and contains 10 to 3000 D-glucose units. Its structure is represented as given this diagram. And here, this is the structure of amylo amylose. So, sorry, this is amylopectin. Structure of amylopectin. It is branched polysaccharide. It is composed of 25 to 30 D-glucose units and joined by alpha glycosidic linkage between C1 of one glucose unit to C4 of another. This one is C1 and this one is C4 of another unit. As in the case of amylose. So similar glycosidic linkage is there in amylose as well as amylopectin. These contain the chains are connected to each other by 1,6 linkage. The molecular weight of amylopectin is 50,000 to 1 lakh, consisting of 300 to 6,000 D-glucose units. Its structure is represented as given below. So this is one chain. Let us see. This is a linear chain, and this one is linked with another linear chain, and this is 1,6 linkage. So one carbon of this unit number 1 is linked with 6 number carbon of another unit with in another chain. So it is branched. So this one is it is like this. So this is branched polysaccharide. Uses of amylopectin. It is an important part of food as bread, rice, potatoes, arrowroot. It is used in manufacture of glucose, dextrine, alcohol. It is used in laundry works for stiffening of textiles. It is used as indicator for iodometric titrations. It is used in paper making and confectionery. Confectionery is making of sweets and some food items. So it is used in manufacturing of starch nitrate, which is used as explosive. It is used in coating and sizing paper to improve the writing qualities. So these are the uses of amylopectin. Then cellulose. Sources of cellulose. Cellulose is a main structural material of plant. It is a main constituent of cell wall of plants. Cotton seed contain 90 to 95%. Wood contain 45 to 50%. And jute contains 60 to 65% of the cellulose. Wood, natural fiber from cotton, flax, hemp, jute are the important sources of cellulose. It is a colorless, amorphous solid, insoluble in water. It is not hydrolyzed as easily as starch. However, on heating with dilute sulfuric acid under pressure, it gives D-glucose units. That means D-glucose only. It is a non-reducing sugar. So the starch plus N here we can see when starch is hydrolyzed, it gives glucose. But this is not the case with cellulose, and it is not hydrolyzed as easily as starch. But when it is heated with dilute H2SO4, then, and this is also under pressure, then it will give cellulose to, it can give D-glucose. So this is the case. Structural formula. Cellulose is a straight chain polysaccharide. It is composed of D-glucose units. These are joined by beta glycosidic linkage between C1 of one glucose and C4 of next unit. So this is C1 and this is C4. But this is, its molecular weight is 50,000 to 5 lakh, and it contains 300 to 2500 D-glucose units. Its structure is represented as given below. So this one is beta glycosidic linkage. So when it is alpha, it it is represented as like this. But when it is beta glycosidic linkage, it is like this. Uses of cellulose. It is a basic raw material in the manufacture of paper and textile, that is cloth. Cellulose is used in manufacturing of gun cotton. Nitrated cellulose contain 3 nitro groups per glucose unit, which is used as explosive like blasting gelatin and cordite. Pyroxylins, lower nitrates of cellulose contain 2 nitro groups per glucose unit, and this pyroxylins used in medicine, photography, cellulose, paint, and lacquers. Celluloid made by warming a mixture of camphor and pyroxylin in alcohol are used for making toys, photographic films. Cellulose xanthate obtained by reaction of wood pulp or cotton linters with carbon disulfide and sodium hydroxide is the basic material for viscous rayon yarn. Cellulose acetate, cellophane, cellulose ether are used for making acetate rayon yarn, protective films, and production of textile film, respectively. Thank you.